Greetings, everyone. I'm Ali, and today I will introduce you to our approach titled Embedding Attention Blocks, designed specifically for the VizWiz Answer Grounding Challenge. This work is a collaborative effort between myself and Professor Chandra Kambapatu. We both represent the WIMS lab at the University of Delaware. Current attention-based methods suffer from one of the following three problems. The attention mechanism is not based on a well-known and well-tested method. The complicated design makes it difficult to re-implement them in other platforms, and the custom design does not allow the usage of pre-trained networks. Our proposed method tries to solve these problems. The squeeze and excitation method is a channel-wise self-attention mechanism widely used in classification networks. It consists of a global average pooling of the input, followed by two linear layers with an interleaved nonlinearity and a sigmoid function. In this work, we present a novel attention module based on the squeeze and excitation method. We start by the SE block and perform the following modifications: changing from self-attention to cross-attention, adding a normalization layer, and replacing the sigmoid function with a softmax. To improve the generalizability, we use pre-trained vision language models. A prime example of such a model is CLIP, which has been trained on a data set of over 400 million publicly available images paired with their corresponding text sourced from the internet. We combine CLIP with the proposed embedding attention block to predict answer groundings. We use CLIP's encoders to encode the image, question, and answer. Next, our proposed block recalibrates the channel-wise image feature maps by explicitly modeling interdependencies between the image feature maps and embeddings. The flexibility of our design makes it possible to use both single-scale and multi-scale image features. For each feature map scale, our embedding attention block is used independently to process the features based on the embeddings. And at the end, all the feature maps are combined to produce the final output. We augment the VizWiz-VQA-Grounding Dataset with the text VQA-X dataset to increase the training size. We evaluate our method in the 2023 VizWiz-VQA-Grounding Challenge. Our method achieves a mean intersection over union accuracy of 74% and holds the first place in this ranking. And thank you for listening.